Hi guys, welcome back to a new video. So in this video we'll be talking about IMONST 2, the second round. So this is senior question 4. Now let's just jump straight into it. Given four circles, this is a Greek letter, it's pronounced as gamma, gamma 1, gamma 2, gamma 3, and gamma 4. Circles 1 and 2, I'll just read it as 1 and 2. Circles 1 and 2 are externally tangent at point A, and then the same thing repeats. Circles 2 and 3 are externally tangent at point B. Circles 3 and 4 are externally tangent at point C. Circles 4 and 1 are externally tangent at point D. Then prove that quadrilateral ABCD is cyclic. Cyclic quadrilateral meaning any quadrilateral that can fit in a circle, right? So what are the characteristics of a cyclic quadrilateral? So one of the characteristics is that the opposite angles add up to be 180. So this is the main thing, okay? So if this is A, this is 180 minus A, something like this. Okay, so this is one of the main characteristics, I'd say, and then we'll be using this very characteristic to solve this problem. Now, first we need to kind of draw the whole picture. So let's move down a little bit. So this is our circle 1, I don't know, gamma 1. Then we will have a gamma 2, bigger one. Somewhere down here. Then this is the third one, a bit bigger again, I guess. I don't know how big it has to be actually, so it's okay. So a bit something like this, and then the last one would be something like this. Yeah, this size. This one could be a bit smaller. I don't know. I just want the difference in the sizes of the circles to be a bit more obvious, I'd say. So this is it. These are all four of our circles, and then from their centers. Okay, this is the center. Okay, this one is a bit hard. So I think the whole construction of this figure would take around like 2 to 3 minutes for me, so please do bear with me. Because if you were to really draw a figure out, I also think you'd take like, I don't know, 2 or 3 minutes. Just that I'm using computer, so things are a bit facilitated. Now for the final line, we have this one. So my drawings are not all accurate, but they at least can give a quite good enough representation. Okay, if two of these lines, okay, so let's call this gamma 1, this one is gamma 2, this one's gamma 3, and then this one's gamma 4, right? So if gamma 1 and gamma 2 are externally tangent at point A, this would be our point A. And then externally tangent means that these two radii are 90 degrees to this line of tangency, which means this whole thing is just a straight line. That's the same thing applies to all the other four lines, right? So for gamma 2 and gamma 3, the point B is here, gamma 3, gamma 4, here, point C, and then this is point D. So gamma 4 and gamma 1, externally tangent point D. So what we want to do is, okay, let me erase a bit of things. I think I want to erase my... Okay, yeah, just nice. Now, let's link up the quadrilateral ABCD, and then let's see if it really is cyclic as they say. Now, a new line over here. This is not really accurate, and I apologize for that. Okay, and then this is okay, good, accurate enough. And then now let's link AB. Okay, good enough. Then the final one we have BC. So it is here, right? And then, as I've mentioned before, one of the characteristics of cyclic quadrilaterals is that their opposite angles add up to 180 degrees. So let me write down again. opposite angles add up to 180 degrees. Okay, so what we want to do is we would like to find that. And note that these are the centers of these circles, so we'll just name them O1, O2, O3, O4. So this is O2, sorry. Then the final one, O4, is right here. And then note that these are the radii, right? So this is the same like this. O2A is the same as O2B, and then O3B is the same as O3C. Oh, sorry. And then O4C is the same as O4D. So we would have, okay, something like this. Now, let's take angles. Let's take angles BAD and BCD to examine. Okay, so we have here, what do we have here? Okay, give me a moment. We have angle BAD plus angle, what do we have here? Angle O1 AD, sorry, this is an O1 plus angle O2 AB equals to 180 degrees because it's a straight line. As we say, this is a straight line. So okay, now let's move down a little bit because we need more space to write some stuff. So we know that this is 180 degrees, right? And then let's name, no, we need to give some notation beforehand. I'm so sorry that I didn't do this earlier. So let us let angles O1A D equals angle O1DA equals to A. I could say alpha. Then angles O2AB equals to angles O2BA equals to beta. And then angles O3BC equals angle O3CB equals to gamma. And then angles O4CD equals to angle O4DC equals to delta. So this is a alpha, and then this is alpha, beta, beta, gamma, gamma, delta, delta. Okay, so 4 of these together, and then we would observe that, okay, no, our alpha should be placed here. Okay, so let me kind of erase this alpha. Oh, okay, sorry. Okay, yeah, just kind of pointing out where the alpha is. Okay, so there's an extra alpha in the circle. I apologize for that beforehand. Basically, what we will have is we can just list out. Give me a moment. Let me rearrange my thoughts. I'm so sorry for that. I'm not here fully prepared. I don't know why. Okay, so what we have here, we will look at this area. So at this area, we will have angles O1 AD plus angles BAD plus angle O2 AB equals to 180, right? So we have angle BAD plus alpha plus beta equals to 180. Now, then for this area, we can look at angles O2BA plus angle ABC plus angle O3BC equals to 180 degrees. So this one and this one we have given notation before. So this one is just basically beta plus angle ABC plus angle, no, O3BC is gamma is 180 degrees too. Now let's move down a bit. Okay, now for this one, for this area, we will have angle O3CB plus angle BCD plus angle O4CD equals to 180 degrees. And then for this one, we can just change it into O3CB is gamma. So gamma plus angle BCD plus angle, this is a delta, is 180 degrees, right? And then finally, we would have for, which area is this? This area. Okay, my figure is a bit messy, so I also apologize for that. Angle O4DC plus angle ADC plus angle O1DA is 180 degrees. Now let's move down a bit. We would have delta plus angle ADC plus this is an alpha equals to 180 degrees. So we have 4 equations here, right? So these 4 equations become equation 1, equation 2, equation 3, equation 4. Now adding up these 4 equations together, now let's move down a bit. So a bit of farewell from our circles. We would have equation 1 plus equation 2 plus equation 3 plus equation 4 will give us 2 alpha plus beta plus gamma plus delta plus our angle ABC plus angle ADC plus angle BAD plus angle BCD is 720 degrees because 480 degrees, right? And then we note that our ABCD itself is a quadrilateral, so its sum of its interior angles. So these are all the interior angles must sum up to 360 degrees. So this means that 2 alpha plus beta plus gamma plus delta is 720 minus a 360 will give us 360 degrees. Alpha plus beta plus gamma plus delta is 180 degrees. Then we will just observe. What do we want to observe? We can just take angles BAD and angles BCD because both of them are opposite angles, right? So angle BAD is 180 degrees minus, what do we have here? 180 degrees minus alpha minus beta. So we would have alpha minus beta. And then angle BCD is 180 degrees minus, sorry, I need to move up again. Angle BCD equals to gamma delta, okay, and 180 degrees minus gamma minus delta. So we see that these two opposite angles add up together. BAD plus BCD equals to 360 minus alpha minus beta minus gamma minus delta. Okay, so all 4 of these add up to 180 degrees, right? So this is 180 degrees itself. So since both opposite angles are 180 degrees, we can just write. Okay, let me write it down here. Okay, since angle, how do I represent angle? So I use this to represent angle. Since angle BAD plus angle BCD equals 180 degrees. I don't know, just draw a circle above and both are opposite angles to each other. Hence, we prove that a quadrilateral ABCD is cyclic, and we are done. So we just write our QED over here, and then yeah, this is the end of the video. I think quite a long proof, not really, it's easy but just tedious, I don't know, in my own opinion. So this is the end of the video. Hope you guys understood everything I said, and then as always, if you support me, you could like and subscribe. I don't know, I'm just begging for likes at this point, I'm so sorry. Okay, so we'll see you guys in the next video, and then yeah, hope you guys can do a bit of practice. Okay, that's it. Ciao.